Hi everyone. In this video, we're going to be doing uh, A-Level Maths 9709, Paper 12, Paper 1, Pure Maths 1, May, June 2025. This paper is 1 hour 50 minutes long, so we'll try to finish within that time limit. So without further ado, let's get started. Okay, so for the first question, we're given a diagram with graphs with equations y equals fx and y equals gx. So these are the graphs that we're given. And in this question, we have to describe fully a sequence of two transformations, which transforms the graph of y equals fx to the graph of y equals gx. And we have to make clear the order in which the transformation should be applied. Okay, so first of all, as you can see, to transform the graph of y equals fx into y equals gx, you would have to shift it down vertically, downwards, followed by stretching it vertically with the scale factor. So now we're going to figure out the 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 downward shift, like about how many units this graph was moved and stretched by in order to produce the graph of y equals gx. Okay, so first of all, let's notice the gradient of like the corresponding section. So let's notice the gradient of this, of y equals fx. So as you can see, let's do the working here. So the gradient here is 5 to 6, so that is 1 divided by 2, so 1.5. And then now let's calculate the same gradient for the same section at for y equals gx, so this section. So as you can see, rise is 2 units as well as the run. So again, your gradient is 2 divided by 2, which is equals to 1. So what does this tell us about the equation about y equals gx? So since the gradient of y equals fx is, half, and that of gx is 1, the gradient of gx is twice that of fx. So the stretch factor should have been 2. So it should have been vertically stretched with scale factor 2. And before that, it should have been shifted down vertically by a certain number of units. So now let's sketch y equals gx before it was stretched. Okay, let's erase all this. Okay, so since it's been stretched with a scale factor of 2, this highest point will be -2 divided by 2 here. And then this lowest point, -4, would be -2 right here. And then this lowest point here, -8, will be 4, -4 right here. So hence, this would be our graph of y equals gx before it is stretched vertically. So we can clearly see that it has been shifted by 1, 2, 3, 4, 5, 6, 7 units vertically downwards. So hence we can say that the graph has been shifted vertically downwards by 7 units. Write down the vector as well. So here the vector would just be 0, -7. And then you should write followed by a vertical stretch of scale factor 2. So this is our final answer for this question. Let's head on to the next question. Okay, so here we're going to have to find the coordinates of the points of intersection of the curve and the line with equations this and this. Okay, so in order to find the points of intersection, we're going to have to solve these equations simultaneously. So let's write down the equations first. So this would be our equation 1, and this would be equation 2. Okay, so what we can do here, so there are two methods that we can use to solve this equation with. So first method would be elimination. So this is where we have one common term in both equations and we subtract that to get rid of that term. Then we'll have an equation with in terms of either x or y only. The other method would be substitution, where we make x or y the subject in either equation and we substitute that into the other equation. So here we can actually use either. So I'm going to use the elimination method. So as you can see, the first equation has the term 2xy, and the second equation has the term 2x only. So in order to make it 2y, 2xy, we're going to multiply y on this equation. So this would just be 2xy plus y times y squared plus 4y equals to 0 times y, which would be 0. So this is our new equation, which we'll call 3. And now we have equation 1 and 3, which both have the term 2xy. So now we're going to eliminate them by subtracting both equations. Sorry, my pen's not working. Okay, so subtract equation 1 and equation 3. We'll get 2xy plus 5y squared minus bracket 2xy plus y squared plus 4y equals to 24 minus 0. So that would just be 24. Okay. So the two xy terms will cancel out. So we will have 5y squared minus y squared minus 4y squared equals to 24. So now let's simplify everything and move everything towards the left-hand side. So we will have 4y squared minus 4y minus 24 equals to 0. So as we can see, all the coefficients are divisible by 4. So we'll divide the whole equation by 4 to get our final equation that we have to solve in terms of y. So as we can see, we got a quadratic equation in terms of y. So now we have to solve this either by using the quadratic formula or factorization or completing the square. So you can use either of those methods. And in my case, I'm going to use factorization. Okay, so the first factor I got is y minus 3 times y plus 2 equals to 0. So let's substitute 0 into each of the factors. So y minus 3 equals 0. You'll get y equals to 3 and y plus 2 equals to 0. you would get y equals to minus 2. Okay, so now we have our y values, but they ask for coordinates, so we have to find the corresponding x values as well. And in order to do that, we can just substitute the y values into either equation that we formed. So in this case, I'm going to substitute into equation 2 because it's the simplest. So let's do that. So we'll have substitute y equals to 3 into 2. Okay, and then this would be 2x plus y, which is 3, plus 4 equals to 0. And then we would have 2x equals to minus 7. And this would give us x equals to minus 7 over 2. So this is a corresponding x value. Let's do the same for y equals to negative 2. So we'll have 2x minus 2 plus 4 equals to 0. And then 2x would be equal to plus 2 minus 4. So 2 minus 4, that would give us 1. Wait, sorry. It would give us minus 2. And then x would be minus 1. So these are our final answers for our x and y. So hence we can write them down as coordinates. X first followed by y. So minus 7 over 2, comma 3, and minus 1, comma negative 2. So these are our coordinates. These are the coordinates of our points of intersection for this question. And if you want to check whether you got the answer correct for this question, you can just substitute these coordinates into either equation and see if you satisfy them. So without further ado, let's head on to the next question. Okay, so here we're told that the coefficient of x to the power 7 in the expansion of this binomial expansion is 12,080. And we're told to find the value of the constant p. Okay, so how do we do this is let's write down the expression first. And we'll take a look. I will take a look in our binomial series formula. So this formula right here. Okay, so let's take a look at this part of the formula. So this formula is for the the fourth term of this equation. So this is equals to n3 a times negative n a to the power of n minus 3 times b to the power of 3. So as you can see, so we can actually make this into a general form where we can write tr plus 1 equals to nr a to the power of n minus r times b to the power of r. So this is the formula that we'll be using to solve our equation. So let's write that down. Okay, now we're gonna substitute our n. So here our n is clearly 5 and our r is unknown. And a would be the first term in here. So basically p x squared n minus r. And then b is 4 over px to the power of r. Okay, so how we do this is we're going to simplify all the terms. So first of all, we have this power. So we're going to distribute it to both p and x squared. So we get p to the power of n minus r times x to the power of 2 times n minus r. So this would just be 2n minus 2r. And then for the next term, 4 over px squared, this would be 4r over p to the power of r times x to the power of r. Okay, now let's simplify everything and substitute n equals to r. Oh, okay, wait, no. Before that, let's separate the constant terms and the x terms. So the p terms will be p to the power of 5 minus r over p to the power of r times 4 to the power of r times x to the power of 2n minus 2r plus r. So 2n would just be 10, and then minus 2r plus r, that's just minus r. And we can simplify further by subtracting the powers, 5 minus r. So this would be p to the power of 5 minus 2r times 4 to the power of r, x to the power of 10 minus r. So this is our general term formula. Now we're just going to equate the power of x into 7, since we're interested in the term with x to the power of 7. So let's do that. So 10 minus r equals to 7. You would get r plus 7 equals to 10. Hence r is equals to 3. So this is our answer for r. Now let's find the equation by substituting r into the constant, into the coefficient part. So we'll have 5 choose 3 times p to the power of 5 minus 2 times 3 times 4 to the power of 3. So let's evaluate everything with the calculator. So 5 choose 3 is equal to 10. 10 times 4 to the power of 3, that's 640. And p to the power of 5 minus 6, that is p inverse 1, which is just 1 over p. So this would be 640 over p. Now let's equate this to 1280. So 640 over p equals to 1280. So p would just be 640 over 1280, which would give us half. So this is our value of p. P equals to 1 over half. So this is our final answer for this question. Let's head on to the next question. Okay, so here we are told that a point P is moving along a curve with this equation in such a way that the x-coordinate of P is increasing at a constant rate of 5 units per second. So, all right, okay. And then for the first part, we're told to find the rate at which the y-coordinate of P is changing when x equals to 9. And we're supposed to give our answer in terms of the constant K. Okay, so what does it mean in mathematical terms when it says the x-coordinate of P is increasing at a constant rate of 5 units per second? So this one we can just rewrite it as dx with respect to dt, which is time. That's basically a rate of change of x. And since it's increasing, this would be just positive 5. So dx dt is equals to 5, nothing else. And then here, we're going to have to find the rate at which the y-coordinate is changing. So by this, we can understand they want us to find the rate of change of y with respect to time. So this would also just be dy dt. So this is what we have to find when x equals to 9. So let's write down all this information. So dx dt is equals to 5. And we want to find out our dy dt. So how do we express dy dt in terms of dy dx? So dy dt has to be dy over something times something over dt. So this something, it has to be the same. So we have dx dt. So here it will just be dy dx. So dy dt equals to dy dx times dx dt. This is the same formula as your chain rule. So yeah. Okay, so we have to find our dy dx in order to solve this question. So let's do that. So we're given the equation of the curve in terms of x. Sorry. So we can write y equals to a times x to the power of 3 over 2 minus 12x. Now we're going to differentiate both sides. So dy dx would just be the derivative of this entire function. So for the first term, a times x to the power of 3 over 2, we can take out the constant term a and just differentiate x to the power of 3 over 2. So first of all, bring down the original power, 3 over 2, times x to the power of 3 over 2 minus 1, which would just give us x to the power half. And now minus the derivative of 12x. So bring down the power 1, multiplied by 12 times x to the power of 1 minus 1, which is 0. That would just give us 12. So this is our derivative. Let's rewrite 3 over 2 times square root, times a square root x minus 12. Okay, and now we're going to substitute x equals to 9. So dy dx will be equals to 3 times a times square root 9 over 2 minus 12. So 3 times square root 9, that is just 3 times 3, which is 9. So 9 over 2a minus 12. Hence, now we can find our dy dt, which is just dx dt 5 multiplied by dy dx when x equals to 9. So just expand the brackets out, you would get 5 times 9, 45 over 2a minus 12 times 5, which is 60. So this is our final answer for this part. Let's head on to the next part. Okay, so here we're told that given that the curve has a minimum point when x equals to 4, find the value of a. Okay, so what do we mean by minimum point? So we know that minimum point is a stationary point, and at any stationary point, our dy dx must be equal to 0. So let's take our general dy dx equation. Okay. And let's substitute x equals to 1 over 4. over 2 minus 12. This should be equal to 0. So simplifying the first term, 3 times 1 over 4 square root, divide by 2, you get 3 over 4a minus 12 equals to 0. Okay, now let's just solve for a. So let's add 12 to both sides. So we have 3 over 4a equals to 12. And to get a, just divide both sides by 3 over 4. So 12 divided by 3 over 4, you would get 16. So this is our value of a. And this is our final answer. So let's head on to the next question. Okay, so for this question, we're told that the equation of a curve is this trig equation for x between 0 and 2 pi. And for the first part, we're told to state the greatest and the least possible values of y. Okay, so in order to do this, let's first write down the equation. So in order to know the greatest and the least possible values of y, we have to know what are the greatest and least possible values of cosine 2x. So as we know, the maximum value of cosine 2x is equals to 1, and the minimum value is minus 1. So the greatest value would just be 2 times 1 plus 3, which is 7. So this is greatest. And then the least would be 2 times negative 1 plus 3. Sorry. 4 times negative 1. Okay. All right. So 4 times negative 1 plus 3, that's negative 1. So this is the least value. And these are our final answers for this part. Let's head on to the next part. So in this part, we just have to sketch the curve that we're given here. All right. So first of all, we have to know how a cosine function looks like. So in case you don't know, our cosine function from 0 to 2 pi, like cosine x, looks something like this. So this is pi over 2, followed by pi, and then this is pi over 3, and then back again at 2 pi. So this is our original cosine function, y equals cosine x. So it is this upside down bell curve shape that we have to sketch. So just giving you a little idea about the function we're going to sketch. Okay, so all right, in order to do this, going to like label our axes first. So this would be 1, 2, 3, 4, 5, 6, and 7. So this is our maximum point, and minus 1 is somewhere here. So this is our minimum point. Okay, and now we're going to substitute values of x into the equation. So let's first substitute x equals to 0. So 4 cosine 2 times 0 plus 3, that would give us 7. So maximum point is, sorry, pen's not working again. All right, sorry for the delay. So 7 is here when x equals to 0. Now let's find for x equals to pi over 2. Sorry. Okay, that would give us negative 1. So somewhere here. Now let's do the same for pi. And this would give us 7. So 7 and pi would be here. Okay, just mark it with a dot and let's do it for 3 over 2 pi. That would give us -1. Okay, that should be somewhere here. All right, and now let's do it for 2 pi, which is equals to 7. Yeah, so these are our points. Let me label them more clearly. All right, so now let's sketch the curve. So this would be something. Oh no. Ah, okay, so this would be our curve. This would be the minimum point, so be the turning point. All right. All right, and now let's write down the curve down there. Okay, so this is the best sketch that we can do for our curve, 4 cosine 2x plus 3. So this is our final answer for this part. Let's head on to the next question. Okay, and now the next part we have to hence determine the number of solutions for this equation for this given domain. Okay, so first of all, they use the word hence in here. So that means we have to use our answer from the previous part in order to solve this question. So we're going to have to use the graph that we sketched in one way or another. Okay, so how do we do that? Okay, first of all, let's examine this equation. So how do we solve this equation graphically? So first of all, on the left-hand side, we have the function that we graphed just now. So we can use this equation that we graphed out. And to solve this, we're going to have to sketch the right-hand side. So y equals to 2x minus 1. All right, so as you can see, this graph would be a straight line. This equation would be a straight line when you graph it. So let's try sketching it. So again, we're going to substitute values of 0 and find out the corresponding values of y from there. So 2 times 0 minus 1, that is -1 right here. Okay, and substitute 2 pi, 2 pi, when you substitute x equals to pi over 2 minus 1, you would get 2.14159. So this would be like 1, 2, somewhere here. Yeah. Okay, and then substituting pi, you would get 5.28. So this is 765. So 5.28 is it's closer to 5, is between 6 and 5. So it's somewhere here. Yeah. Okay, now let's just join these 3 points all together. In the exam, please use a ruler. I'm doing this with freehand on a laptop, so I can't use a ruler. Okay, so this is our sketch y equals to 2x minus 1. So as you can see, there is 3 points of intersection, 1, 2, and 3. So we can conclude that there will be 3 solutions for this equation. So this is our final answer. And by the way, you don't have to sketch the straight line if you can already visualize it. I have to sketch it because it's hard for me to visualize. So take note of that. So without further ado, let's head on to the next question. Okay, so in this question, we are given a diagram which shows the curve with this equation and the line y equals to 6 minus 3x. So this is the line here, y equals to 6 minus 3x. And this says y equals to 9 over 5x plus 4 to the power of half. And we're told that the line and the curve intersect at the point P, which has y coordinate 3. So this is crucial information. And so we're told to find the area of the shaded region. Okay, so first of all, let's examine the shaded region and see whether we can split it up into simpler shapes. So I can see that we can make a triangle out of this, like when we cut the shape at point P. So I'm gonna let this triangle be B, and then we have this irregular area called A, which we have to do, which is the area under this curve from 0 to the x coordinate of P. So we're gonna have to integrate this function with the limits of xp and 0 to find this to find the area of A. Okay, so first of all, let's find the x coordinate of P. Okay, so to do that, we're already given the y coordinate 3, and we know point P is just the point of intersection of the two curves, so they exist on both the curve and the line, so you can just substitute into either one. In this case, I'm gonna go for the line. So sub y equals to 3 into y equals to 6 minus 3x. So you get 6 minus 3x equals to 3. Minus 3x would be equals to 3 minus 6, that's minus 3. And then x would be equals to 1. Hence, xp is 1. Okay. Now we can find the area of A. So that would be, the limits will be 1 and 0, and we have to integrate this function right here. So 9 over 5 plus 5x plus 4 to the power of half with respect to x. Okay, first of all, in order to make this simpler, we're going to take out the constant term, 9, and keep it outside the integral. So now we have 1 over 5x plus 4 to the power of half. In order to make this easier, we're going to change the power from half to minus half. So this would just be bracket 5x plus 4 to the power of negative half dx. Okay, so now let's integrate this function. So in order to integrate this type of function, a linear function raised to a power, we're going to have to first write down the linear function and add 1 to the outside power. So minus half plus 1, that's half. And then we divide by that new power. So divided by half. And then we divide by the derivative of the linear function. So here, when you differentiate 5x plus 4, you'll just get 5. So divide by 5. And don't forget to put your limits. Okay, now we're going to substitute 1 and 2, 1 and 0. Okay, so substituting 1, you get 5 plus 4 to the power of half, which is 9 to the power of half, so that is 3 over 5 divided by 2. And then minus, substituting x equals to 0, you'll get 4 to the power of half. So that is 2 over 5 over 2. So just type all this into your calculator. So this would give you 18 over 5 units squared. So this is our area for A. Now we have to find the area of B. So as you can see, B is a triangle, a right angle triangle. So we have to find this length and this length. So for this length, this vertical height is just the y coordinate of P. So it's just 3. And then for the base, it would be the length from this intersection point to here. So we have to find this intersection point, which is very simple to do. Just substitute 6, just substitute 0 into the straight line equation. You'll get 6 minus 3x equals to 0, which would give you 3x equals to 6, and you'll get x equals to 2. So this is 2. So 1 minus 2, this is just 1 unit. So hence B is half times the base, which is 1 times 3, which is the height. So this would be 3 over 2 units squared. Sorry, this is supposed to be units squared. So now we can find our area by just adding these areas up. So 18 over 5 plus 3 over 2. Type it into your calculator. You would get 51 over 10 units squared. So this is our final answer for this question. And if you want to check whether your integration is right, just type this exact integral into your calculator and see whether you get 18 over 5. So this is our final answer. Let's head on to the next question. Okay, so here we have to prove this identity in here. Sorry, penis. Okay, good. So we have to prove this identity here. So for proving identities question, what you should do is you should start from the more complex side. So in this case, the right-hand side seems to be more complex. So we are going to start from there. Okay, so let's write down sine, cosine, plus 7 cosine squared over 1 minus 4 cosine squared theta. Okay, so in order to start this, let's start factoring out terms from both the numerator and the denominator. So from the numerator, we can see that we can factor out cosine theta. So let's do that. So this would give us bracket sine theta plus 7 cosine theta. Okay. And then now, okay. Hmm. All right, let's not do this. Okay, so I believe a better way to do this is to factor cosine square theta. So let's do that. So cosine square theta, factoring that out, you get sine theta over cosine theta plus 7. And then factoring out cosine square at the denominator, you'll get cosine square theta bracket uh, 1 over cosine square theta minus 4. Okay, so the cosine square thetas cancel out. So now we have to evaluate sine theta, cosine theta. So in our formula sheet, we're given this identity, tangent theta equals to sine theta over cosine theta. So we can write this down as tangent theta plus 7 over, let's combine this 1 over cosine squared theta minus 4 into a single term. Should we? Okay, all right, let's rewrite the 1 as cosine square sine square instead. So sine square theta plus cosine square theta over cosine square minus 4. Okay, and now we're going to simply split this fraction up. So we'll get sine square theta over cosine square theta plus cosine square theta over cosine square theta minus 4. Okay, so simplifying all that, so sine square over cosine square theta, you would obviously get tangent square theta. So this would be tangent square theta, and cosine square over cosine square, that's plus 1 minus 4. Simplifying all this, you would get tangent theta plus 7 over tangent square theta minus 3. Yep, so this is our final answer. We have proven the identity. So let's head on to the next part. Okay, so hence, now we have to solve this equation for this domain that we're given between 0 degrees and 180. Okay, so since we're given the word hence, we have to use our identity that we have proved from the previous part to solve this equation. And as we can see, the left-hand side of this equation is also a part of our identity that we proved in here. So we can just rewrite this equation as tangent theta plus 7 over tangent square theta minus 3 equals to 5 over tangent theta. Okay, and now we can cross multiply. So this would be tangent theta times tangent theta plus 7 equals to 5 times tangent square theta minus 3. Okay, now we're going to expand out the brackets. So tangent square plus 7 tangent theta equals to 5 tangent square theta minus 15. Okay, and now let's move everything to the right-hand side. So 5 minus tangent square minus 1 tangent square, that will give us 4 tangent square theta, and then minus 7 tangent theta, followed by minus 15. equals to 0. Okay, now we're going to, so as we can see, we have a quadratic equation in terms of tangent theta. So let's just do a simple substitution where we'll let t equals to tangent theta. So this would be 4t squared minus 7t minus 15 equals to 0. So you can again use the quadratic formula or factorization or completing the square, whichever you feel most comfortable with. So here I'm going to factorize. So I got t minus 3 and 4t plus 5 equals to 0. So in t minus 3, let's equate it to 0. So we'll get t equals to 3. And then the next term, our next factor, also equated to 0. 4t plus 5 equals to 0. And 4t would be minus 5. And t would be minus 5 over 4. Now let's substitute t equals tangent theta back because we're interested in theta, not t. So tangent theta equals to 3. And tangent theta equals to minus 5 over 4. Okay, so here we have two solutions for tangent theta, one positive and one negative. And the range for tangent theta is negative infinity and infinity, so we don't have to reject any values in here, so we can keep both. All right, now to find theta, let's first draw our unit circle. So let's look at our domain first. So theta is between 0 degrees and 180. So it covers the first two quadrants only. So this and this. So the first quadrant is A. So that means all the trig ratios are positive, including tangent. So this is positive. And then the second quadrant is S. So this means only sine is positive. So tangent is negative. So this is a negative sign. And since we have both positive and negative values, we can take angles from both quadrants. Okay, so let's solve tangent theta equals to 3. So since this is positive, this theta would be in the first quadrant. It would basically just be the basic angle. So theta, just take the inverse and type it into your calculator. Make sure your angle units is in degrees because the domain is in degrees. So we get 71.6 degrees to 1 decimal place. Okay, now let's solve the second equation, tangent theta equals to minus 5 over 4. So here theta would be, okay, since here tangent theta is negative, here the theta would be in the second quadrant. So it would be an obtuse angle like this. And in order to get this obtuse angle, you'd have to first do 180 minus alpha, which is the basic angle that you get when you're taking the inverse. So here theta would just be 180 minus alpha, which is tangent inverse the absolute value of 5 over 4, which is just 5 over 4. So type it into your calculator. You would get 128.7 degrees to 1 decimal place. So this would be our final answer. And answers in degrees should always be given to 1 decimal place. It's stated on the front cover of the question paper. So these are our final answers. And if you want to check whether your answers are correct, just type the exact values in back into the equation and see whether both sides are equal to each other. So without further ado, let's head on to the next question. All right, so in this question, we're shown a diagram with with a circle that has this equation in the general form and the line y equals to -2. So this is the line y equals to -2, and we're shown the circle. And we're told that the line intersects the circles at the points A and B. So here we're shown A and B in the diagram, and the center of the circle is C. So for the first part, we have to find the coordinates of A, B, and C. Okay, so first of all, let's find the coordinates of A and B. It's the easiest. So let's write down the equations first, the equation of the circle first. So it's like this. This is the first equation, and then followed by y equals to -2. This is the second equation. So in order to solve this, we're going to solve this simultaneously. And since we are given an equation in terms of -2, I mean, in terms of y, we're going to substitute that into the first equation. So we're going to use substitution here. So let's substitute y equals to -2 into 1. So we'll get x squared plus -2 squared, so 4, minus 14x plus 8 times -2, so -16, plus 36 equals to 0. So simplifying all this, we'll get x squared minus 14x is equal to 4 minus 16 plus 36, which should be plus 24, all equals to 0. So here we got a quadratic equation in terms of x, and we have to solve it. So you can again use your quadratic formula or factorize or complete the square, whatever method is most suitable for you. So here again, I'm going to factorize. So you'll get x minus 12 and x minus 2 equals to 0. So let's equate each of these factors to 0. So x minus 12 is equals to 0. So you get x equals to 0. And equate x minus 2 equals to 0. So you get x equals to 2. Okay, so now we have to find which one is for point A and which one is for point B. So as you can see, point A is closer to the y-axis than point B. So of course, this will have the smaller x coordinates. So this would have the x coordinate 2, and B would have the x coordinate 12. And for both, the y coordinate is the same because they both lie along y equals to -2. So y coordinate for both will be -2. Hence, we can write A is equals to 2 bracket comma -2, and B is 12 comma -2. So these are final answers for B. Now let's find C. Okay, so to find C, we have to first analyze the equation of the circle. Okay, so this is in the general form. And personally for me, I like to transform it into the form x minus a squared plus y minus b squared equals to 0. And the center would be given to us by a and b. So let's transform it into this form. So first, let's write down our equation. X squared minus 14x plus y squared plus 8y plus 36 equals to 0. Okay, so now to complete the square, so let's complete the square for x separately and y separately. So in order to complete the square, the coefficient of x squared has to be 1. So in this case, it clearly is, so we can go ahead and start. So this would be x minus, because the coefficient of x has a minus sign, 14 divided by 2, which is 7 squared, minus 7 squared. So 49. Let's do the same for y. So we have bracket y plus 8 divided by 2, which is 4 squared, minus 4 squared, which is 16, plus 36. So let's move all the constants to the right-hand side. So we'll have x minus 7 squared plus y plus 4 squared is equal to 49 plus 16 minus 36 equals to 29. So this is our equation of circle in this form. So hence we can clearly see that our center is 7, comma, minus 4. So this is our final answer for our A, B, and C. So now we can head on to the next part. All right. So now we have to find the angle ACB in radians, and our answer should be given to 3 significant figures. Okay, so let's sketch the angle ACB in the diagram. So this angle is something like this. So let's label this theta. So in order to do this, we are first going to have to find the lengths of all the sides of this triangle ACB. So first of all, let's state the length of AC, which is clearly the radius of the circle. So A is on the circumference and then C is the center. So the distance from there would be the radius of the circle. So okay, this is r squared in our formula. We can clearly see r squared is 29. So r would be square root 29. So AC is square root 29. Same for a CB, which is also square root 29. So ACB is an isosceles triangle. Okay, so let's write that down. AC equals to CB equals to square root 29. Okay, now we have to find AB. So AB, it would just be the distance between the x coordinates. So it would just be 12 minus 2, which is equals to 10. So AB would be 10 units. Okay, so since this is an isosceles triangle, we can split this up into 2 at the point C. So now we have 2 right angle triangles with the base being 5 and this also being 5. So 5 squared 29 and 5 squared 29. So we will get half of the, we'll get half of theta. So theta over 2 would be, okay, so opposite over hypotenuse. So sine inverse 5 over square root 29. Okay, and then now we can write down theta would be 2 times sine inverse 10 divided by 2 over square root 29, which is equal to, okay, remember to change to radian mode. This would be 2.38 radians to 3 significant figures. So this is our final answer for this part. Let's head on to the next part. Okay, so here we're told the chord AB divides the circle into two segments. The chord AB divides the circle into two segments. Then we have to find the area of the larger segment. Okay, so let's take a look at our diagram here. So this is the chord AB they're talking about, and the smaller segment is above AB, and the larger segment is below AB. So the larger segment, it consists of the triangle ABC as well as this major arc that I'm going to shade right here with this reflex angle. So in order to find the area of that, we first have to find the area of ACB as well as the area of the major arc, the major sector. Sorry. So let's do that. So major sector. We can use the formula here, half r squared theta, where theta should be in radians. So that would just be half square root 29 squared, so just 29 theta. So this would be, let's write down the exact value, 2 pi minus 2 sine inverse 5 over square root 29. So simplified, we would get, let's write the exact form as well. So 29 bracket pi minus sine inverse 5 over square root 29. So this is the area of the major sector. Now we're going to find the area of the triangle ACB. Okay, so to find the area of the triangle, excuse me. Okay, so to find the area of the triangle, we first have to use the formula half AB sine C. So our C would be the angle ACB that we found previously, and the sides AB would be the sides that are between the angle ACB, so AB and CB. Okay, so let's substitute that. So half times square root 29 times square root 29 sine of BAC. So that's sine 2 sine inverse 5 over square root 29. So type all of that into your calculator. Sine 29 times half, that is 10 units squared. Hence, the larger segment just be the areas of these two areas combined. So just 29 times pi minus sine inverse 5 over square root 29 plus 10. So adding those up, you would get 66.6 units squared to 3SF. So this is our final answer. Let's head on to the next part, into the next question. So here we're told that the equation of a curve is such that the second derivative is this, and it's given that the curve has a stationary point at this exact point, which we are given the coordinates of -2 and 19. So for the first part, we just have to find an expression for dy dx. Okay, so first of all, we should know that if you differentiate dy dx, you will get the second derivative d squared y over dx squared. So in order to get dy dx from here, we're just going to have to integrate this with respect to x dx. So dy dx would just be the integral of minus 24 over x cubed dx. And then now we're going to take out minus 24 because it's a constant. So let's do that, minus 24. Now we'll have to only integrate minus x cubed, 1 over x cubed. So integrating that would just be, changing that would also be x to the power of -3 dx. So minus 24 integrating x to the power of -3, that would be x to the power of -3 plus 1, -2 divided by the new power, -2 plus c. So -24 divided by -2, that is 12 x to the power of -2 plus c. Okay. And now to find c, we're going to make use of this piece of info, stationary point at this exact point. So we know at the stationary point, dy dx will be equals to 0, since the tangent of at that point will have the gradient 0. It will be horizontal. So we can, sorry, or we can substitute x equals to -2 because the x coordinate is -2, and dy dx equals to 0. So we will have 12 times 2 to the power of -2 plus c equals to 0. So hence, c would be minus 12 over 4, which is -3. Hence, dy dx is equal to 12x to the power of -2 minus 3. So this is our final answer for this part. Let's head on to the next part. Okay, so here we're going to have to find the x coordinate of the other stationary point of the curve and to determine the nature of the stationary point. Okay, so again, to find the other stationary point of this curve, just equate the dy dx to 0. So we will get 12x to the power of -2 minus 3 equals to 0. Rewriting this, we'll get 12 over x squared equals to 3. Okay, now multiplying x squared on both sides, we get 3x squared equals to 12. And then x squared would just be 12 divided by 3, which is 4. So in order to find x, just take the square root on both sides. So you will get x equals to square root 4, which is plus or minus 2. So we're already given the stationary point with the x coordinate of -2. So we're not interested in that, so we're going to reject the -1. So hence, x is equals to +2. Okay, and now for the second part of the question, to determine the nature of the stationary point, just substitute your x coordinate into the second derivative. So let's do that. So square y dx squared is equals to minus 24 over 2 cubed. So this would give us minus 3, and minus 3 is less than 0. And when your dy dx is negative, the stationary point is a maximum, and vice versa. If the dy dx is positive, it would be a minimum. So hence, we're going to say the stationary point is a maximum point. So this is our answer. So now we can head on to the next question. Okay, so for this part, we're just gonna have to find the equation of the curve. So to do that, we have to find an expression for y in terms of x. So we know the expression for dy dx is equals to 12x to the power of -3. -2, sorry, minus 3. And to find y, just take the integral on both sides with respect to x. So y would just be the integral 12x to the power of -2 minus 3 dx. All right. Now to find this, we're going to first integrate 12 x to the power of -2. So we'll take out the constant term first, which is 12, and then integrate x to the power of -2. So in order to do that, just, sorry, there's an extra line. To do that, just add 1 to the power. So -2 plus 1, that's just -1, divided by -1. And to integrate, and then minus the integral of 3. So that would just be 3x plus c. Okay, so simplifying this, we'll get 12 divided by -1, that's -12, and x to the power of -1, that's over x. So -12 over x minus 3x plus c. Okay, and now we're going to substitute -2 and 19 to this equation to find c. So that would give us -12 divided by -2 minus 3 times -2 plus c equals to 19. So c would be 19 minus 6 minus 6. Yeah, so -12 divided by -2, that's 6 plus 6. So that's 12. So 19 minus 12, that is 7. Hence, y is equals to -12 over x minus 3x plus 7. So this is our final answer for this question. Let's head on to the next part. Okay, so in this next part, we're going to have to find the equation of the normal to the curve at the point where dy dx is equals to -9/4 and x is positive. And we have to express our answer in the form of this, where p, q, and r are integers. Okay, so in order to do this equation, we have to first find our x value, we have to use this piece of information first. So just substitute our expression for dy dx 12 times x to the power of negative 2 minus 3 equals to negative 9 over 4. So just solve for x. So 12 times x to the power of negative 2 equals 2. 3 minus 9 over 4. That's 3 over 4. And then x squared. And then multiply x squared on both sides. So 3 over 4x squared is equal to 12. And then x squared would just be 12 divided by 3 over 4, which is 16. And hence x will be the square root of 16, which is plus or minus 4. But here we are clearly told that x is positive, so we are going to reject minus 4. Hence, x is equals to 4. Okay, now we're going to find the y-coordinate of the point at x equals to 4. So y, okay, we know the equation of y is equals to minus 12 over x, so 12 over 4, minus 3 times 4 plus 7. So that would be minus 12 over 4 minus 3 times 4 plus 7, which is minus 8. So hence, these are our coordinates, 4 and negative 8. Okay, so to find the equation of the normal, we first have to know the format of a equation of the normal. So the normal is basically a straight line. So its format is going to be in terms of y equals mx plus c, where m is the gradient and c is the y-intercept. So in order to find m, let's do a little sketch. So this is the normal, and this is the tangent. And the normal is perpendicular to the tangent. And to find the equation of the normal, we have to use the fact that the gradient of the normal times the gradient of the tangent is equals to negative 1, because they are perpendicular to each other. So our gradient would just be minus 1 divided by the gradient of the tangent, which is given by dy dx. So negative 1 divided by negative 9 over 4, which is minus 1 divided by negative 9 over 4, which would give us 4 over 9. So this is our m value. So we got y equals to 4 over 9x plus c. And now we are going to sub x equals to 4 and y equals to negative 8. So this would be minus 8 equals to 4 over 9 times 4 plus c. Hence, c would be minus 8 minus 16 over 9. That's minus 8 minus 16 over 9. That's minus 88 over 9. Hence, our final answer is y equals to 4 over 9x minus 88 over 9. So in order to make all of these integers, let's multiply everything by 9. So we'll get 9y equals to 4x minus 88. In order to make it into this form, we're going to have to make our x term first. So let's move everything towards the right-hand side. So this would be 4x minus 9y minus 88 equals to 0. So this is our final answer for this question. Let's head on to the next question. Okay, so here we're told that the first, second, and third terms of an arithmetic progression are 4k, k squared, and 8k respectively, where k is a non-zero constant. So for the first part, we have to find the value of k. Okay, so let's use the formula from the formula sheet for arithmetic series. So this is one formula we're given. So this formula tells us how to find the nth term of an arithmetic series. So A is the first term, and then D is the common difference between the terms. So let's write that down. Un plus A plus n minus 1 D. Yeah, so an arithmetic progression is something like 1, 3, 5, 7. Basically, you just add like a constant term to each to get the next term. So this is an arithmetic progression. Or you can also like minus as well by a constant term. So you'll have 1, minus 1, minus 3, minus 5, and so on and so forth. Okay, so let's find our U2. So U2 is 4k, which is the first term, plus 2 minus 1, D. So 4k plus D. And U2 is just k squared. Okay, now let's make D the subject of this equation. So D is equals to k squared minus 4k. And now we're going to find U3. So that's A, which is 4k, plus 3 minus 1, which is 2, D. And that's equals to 8k. So 2D is equals to 8k minus 4k, which is just 4k. And we get that D is equals to 2k. So these are our two equations. And let's equate them to find k. So we got k squared minus 4k equals to 2k. And then this would be k squared minus 4k minus 2k. So minus 6k equals to 0. And then factor out k. So we'll have k times k minus 6 equals to 0. So solving this, we'll have k equals to 0. But they clearly said that k is a non-zero constant, so this has to be rejected. So the second solution would be k minus 6 equals to 0, which would give us k equals to 6. So this is our value of k. Let's head on to the next part. Okay, so here we're going to have to find the sum of the first 20 terms of the progression. Okay, so let's take a look at the formula sheet again. So this is the formula we're interested in. It's the sum of the first n terms, Sn. We're given two equations of this term. So the first equation, where A again is the first term and L is the last term. But then we don't know what the last term was going to be. Like they didn't give that to us directly in the question. So hence we're going to use the second formula in here. Half n times 2a plus n minus 1 times d. So let's write it down as n equals to half n times 2a plus n minus 1 d. Hence, we can substitute n equals to 20. So S20 equals to half times 20 times 2a. So a is equal to 4k. So 2 times 4k, that's 8k. So 8 times 6 plus n minus 1, which is 19. Sorry, which is 19, and then d is equals to 2k. So 2 times 6, that is 12. Okay, now just type all this into your calculator. So you'll get 2,760. So this is our final answer for this part. Let's head on to the next part. Okay, so here we are told that the fourth and sixth terms of a geometric progression are 36 and 6 respectively, and the common ratio of the progression is positive. And here we're going to have to find the sum to infinity of the progression, and we have to give our answer in this form where a, b, and c are integers. Okay, so let's take a look at our formula sheet again. So here we have formulas for a geometric series. So we're going to take a look at this formula, which helps us to find the nth term. So as you can see, it is un equals to a, where a is the first term, times r, where r is the common ratio to the power of n minus 1. So let's write that down. And by the way, a geometric progression is a progression where okay, so as I was saying, a geometric progression is something where you multiply by a number. So you'll get 1, then the next one will be 2, and then you multiply 2 again. You'll get 4, 8, 16, 32, and so on and so forth. Yeah, so this is what a geometric progression is in general. Yeah, so let's substitute n equals to 4 for the fourth term. So we'll have n a times r to the power of 4 minus 1, which is 3. And that is equals to 36. Okay, so our first equation would be a times r cubed equals to 36. Now let's find our sixth term. U6 would be a times r to the power of 6 minus 1, which is 5. That's equals to 6. So second equation is a times r to the power of 5 is equals to 6. This is our second equation. Okay. Now let's make let's take the second equation and factor out a times r cubed. That's equals to, oh, sorry, this is 6. 6. And now we're going to substitute 36 r squared. We get 36 r squared equals to 6. So r squared is 1 over 6. Hence, r would just be the square root of plus or minus 1 over 6. But in the first question, in the info, they told us that the common ratio is positive, so we're going to reject negative. Hence, r is equals to the positive square root of 1 over 6. Okay. Now we have to find a. So just substitute into r cubed. So a times square root 1 over 6 cubed equals to 36. So this would give us 1 over 6 times square root 1 over 6. 6 over square root 6 over 36 equals 36. And then this would give us a is equal to 36 squared over square root 6. So this would give us 6 squared 1296 divided by 6. That's 216 square root 6. So this is our first term a. And now we have to find the sum to infinity. So the formula for sum to infinity is here. So s to the infinity is a over 1 minus r. So let's substitute that. So sum to infinity is a over 1 minus r. Let's substitute the terms. 216 square root 6 over 1 minus square root 1 over 6. Okay, in order to make this into an integer, let's multiply both the numerator and the denominator by square root 6. So this would give us square root 6 minus 1, and then 216 times 6 is 1296. So this answer is in our suggested form in here that we have to give in. Yep. So this is our final answer for this question. Let's head on to the next question. Okay, so here we're gonna have to express this in the form x plus a squared plus b, where a and b are integers. So basically we have to complete the square in here. Okay, first of all, let's write down the formula, the equation. And now in order to complete the square, we have to first make sure the coefficient of x squared is equals to 1. So we will get x plus 2 squared. Oh, and the constant term in the square, we're gonna have to take the coefficient of 4 of x and divide it by 2. So we'll get 4 divided by 2, which is 2. So x plus 2 squared minus 2 squared, so minus 4 plus 2. Then we'll get x plus 2 squared minus 2. So let's check whether it's in the form x plus a squared plus b. Yes, it is. So a is 2 and b is minus 2. So this is our final answer. Let's head on to the next question. Okay, so here we're told that the functions f and g are defined as follows. So fx is our previous equation, and then the domain is x is less than or equal to -2. Okay. All right. And then gx is minus x minus 4. So it's a straight line for x equals to or more than -2. All right. So for the first part, we're going to have to find an expression for f inverse x. Okay. So first of all, let's sketch fx. So the domain for fx is less than or equal to -2. Now, what do we know about -2? So -2 is actually where the turning point of our function is, because if you take a look at our completed the square form, when you put x equals to -2, we'll get 0 squared minus 2, which is -2, and this would give us the minimum point, so the lowest point on the quadratic curve. So it's somewhere here, and then for x equals to less than -2, it would go something like this. So this is what fx looks like. And so now we can sketch f inverse x by just reflecting across the line y equals to x. So this would be somewhere something like this. Yeah, so this would be something like this. So this would be below the x-axis and on the right-hand side of the uh, y-axis. Okay, so now that we know what f inverse x looks like, we're ready to find it. Okay, so first of all, let's write down fx as the completed square version. So that's x plus 2 squared minus 2. And now replace fx with y. So y equals to x plus 2 squared minus 2. And now we're going to swap the x's and y's. So all the x's becomes y and all the y's become x. So this would be x equals to y plus 2 squared minus 2. Okay, now let's isolate for y plus 2 squared. We would get x plus 2. Okay, and then now let's take the square root on both sides. So we'll get plus or minus x plus 2. All right, so here we have to reject either the positive or the negative square root. So as you can see in our curve, the value of y is always negative in our case. So hence we have to take the negative square root, so we'll reject positive. Hence this would be y plus 2 equals to negative square root x plus 2. Okay, and then isolate y, so we'll get y equals to negative square root x plus 2 minus 2. Now replace the y with f inverse x. So this is f inverse x equals to oh my gosh, minus x minus square root x plus 2 minus 2. So this is our final answer for this question. Let's head on to the next question. Okay, so here we're going to have to find an expression for gf inverse x. So in case if you are getting confused by this is just inverse of gfx. So it's the inverse of a composite function. Okay, so first of all, we have to find gf of x. All right, so gx is minus x minus 4. And to find gf of x, just substitute x with fx. So we'll get minus x squared plus 4x plus 2. And minus 4. So this will give us minus x squared minus 4x minus 2 minus 4. So this would be minus x squared minus 4x minus 6. Now we're going to factorize out -1, so we'll get negative x squared plus 4x plus 6. Okay, and now let's change this to complete the square formula. So as you can see, our coefficient of x squared is 1, so we are ready to do that. So this would be x plus the coefficient of x squared x divided by 2. So this is x plus 2 squared minus 2 squared. So minus 4 plus 6 bracket. So this would be minus x plus 2 squared, 6 minus 4, 2. 2 minus 1, that's minus 2. Okay. So this is our expression for gf of x. Okay, so to define gf of x, okay, let's sketch gf of x now. So first of all, the turning point of the graph would be at, again, x plus 2 equals to 0 at x, so that would be x equals to -2, so somewhere here. And the turning point would be at here at 0 squared minus 2. So somewhere 0 squared minus 2, that is somewhere here. And then since it is negative, since the coefficient of x squared when expanded is negative, this would be a maximum point. So the curve would look something like this. Okay. And now to sketch the inverse function, it would be something like this. So f inverse x, it would be, the x values would be negative mostly. Okay, so x values would be negative and the y values would be both positive and negative. So that's the case. All right. G f inverse x. All right. So now we're ready to find it. So replace g of x with y. And swap the x's and y, so this becomes x equals to minus y plus 2 squared minus 2. Okay, and now add 2 to both sides, so this x plus 2 equals to minus y plus 2 squared. Sorry, something's wrong. Okay, y plus 2 squared. And now we're going to divide by 1 on both sides, so y plus 2 squared is minus x minus 2. Okay, and now, right. Okay, and now we're going to take the square root on both sides. So this would be plus or minus negative x minus 2. Okay, so in order to get, in order to decide which one to reject, we're going to have to see our y values. So all of our x values are negative. So this would be like, so x has to be more than or equal to negative 2. Okay, so yeah, has to be that. And the values of y, they are for both. So yeah, we're just going to take both the positive and negative square root. So y would be equal to, okay, let's take the negative square root as well. X minus 2 minus 2. And now just replace the y with g f inverse of x equals to minus square root minus x minus 2 minus 2. Oh, sorry. So this is our final answer for this question. And we have come to the end of the paper. So I hope you found this video helpful. And if you did, please like, share, and subscribe to this channel for more future math past paper solving videos. And please comment if you have any doubts and queries regarding this video and any errors that I made in this video. And I will see you again next time. Okay, thank you.